So another type of triangle congruence is called hypotenuse leg, or HL, and this only works with right triangles. So if you have two right triangles, and I can see that because it's denoted with this little symbol here that tells us that this is a 90-degree angle. If the hypotenuse, so here's your hypotenuse, and one of the other legs, so in this case it's this one, so if the hypotenuse and one of the other legs are congruent, then we can say that both of these triangles are congruent. So here I can say that triangle OBW is congruent to, and here I have to make sure I write it in the correct order. I know that O is congruent to A, and B is congruent to M, and W is congruent to N. So triangle OBW is congruent to triangle AMN. So now we know all the different congruency theorems and postulates, so we can look at some more examples. If we look at this first example, the first thing I notice is that these angles are congruent because they're both 90 degrees. And I have two sides that are congruent here and another set of two sides that are congruent here. So is side-side angle a congruency postulate that we learned? No, side-side angle is not valid at all. So I can't use that. But we just learned about hypotenuse leg. So let's see if we have that. We have right angles, so that's good. The hypotenuse is congruent in both triangles, so I have the hypotenuse. And a leg is congruent in both triangles. So this is a type of problem where we have hypotenuse leg. So yes, these are congruent by hypotenuse leg congruency. Let's look at this next one down here. Oops. Here I see that I have this side is congruent to this side, and this side is congruent to this side. They don't tell me any information about any angles, so I can't use side angles side. But maybe I could use side, 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 so SSS. And I can because these triangles share this side. So I can say that this side is congruent to itself. And remember, that is called the reflexive property. So now I have side, side, side. So these are congruent by SSS. What I would like you to do is pause this video and go ahead and see if you can answer this last one. So here I know that this angle is congruent to this angle. And I can also say that this side is congruent to itself since they share this side. So I have a side and an angle. Do I know anything else? No, in geometry we can't make any assumptions. I can't assume that this side is congruent to this side or that this side is congruent to this side. So without any other information, I can't say that they're congruent because all I know is one angle and one side. So this would be a case where we have not enough information. So now that we know the 5 congruence postulates and theorems, we can use these postulates and theorems to prove that two triangles are congruent. In a geometric proof, you always begin with your given statements. So here they tell me that line segment DH is congruent to line segment HG. So G, whoops. Let's fix that here. So line segment DH is congruent to line segment HG, and that is given. So that's the first congruent given statement. They give me a second given statement. So EH, line segment EH, is congruent to line segment HF, and that is also given. You always want to check your diagram and make sure that the given information is labeled. So DH is congruent to HG, and EH is congruent to HF. So that's already marked and labeled for us, so that's nice. So I'm trying to figure out how to prove that triangle DEH is congruent to triangle GFH. That's what we're trying to prove right here. So you know the statement that you're trying to prove is always going to be the last thing. So I know that my final statement is going to be triangle DEH is congruent to triangle GFH. So I'm trying to go to here, my final step. I got to figure out how I can get there. Right now, we have two sides that are congruent and another pair of sides that are congruent. They don't give me any other information about any other sides, but I do know something about an angle. Don't we know that this angle is congruent to this angle by vertical angle theorem, right? Because here I have a pair of vertical angles. So I know that angle DHE is congruent to angle GHF because of the vertical angle theorem. So let's write that down. DHE is congruent to angle GHF by vertical angles. So now that we know that we have a side, an angle, and a side, we can say that these two triangles are congruent by SAS congruence. Now let's make sure our congruency statement is true. So is D really congruent to G? Yeah. D is the one tick mark to the angle. G is one tick mark to the angle. Is E congruent to F? So E is the one next to 2. F is the one next to 2. And then H is congruent to itself by the reflexive property. So we've written our congruence statement correctly, and we've just proven that these two triangles are in fact congruent. Let's try another one. Again, we're going to start with our given information. So they tell us that line segment JK is congruent to line segment HG. So JK is congruent to HG, and we can see that they've added the hash marks there. And that's given. They also give me the statement line segment JH is congruent to line segment GK. Where'd my pen go? There we go. And that's also given. And we can see that they've marked that with a hash mark there for both of us as well. So now what do I know? Well, I know that these sides are congruent, and I know that these sides are congruent. They don't tell me anything about any angles, but isn't this side a part of both triangles? This triangle here and this triangle here. So can I say that this side is congruent to itself? So we know that HK is congruent to HK by the reflexive property. And again, all the reflexive property tells you is that everything is equal to itself, right? this line as a part of this triangle is congruent to this line as a part of this triangle. It's the same thing, it's congruent to itself. So now we have a side, and a side. On this triangle, side, side, side. So we can use our proven statement here. So triangle HGK is congruent to triangle KJH by SSS congruence. So if we look at example 3, our given statement is that line segment QM is congruent to line segment ML. So this part is congruent to this part. It's already marked for us. And that angle Q and angle L are right angles. So I've written down my given statements. Well, since angle Q and angle L are both right angles, that means they both measure 90 degrees. Well, that means that they're congruent. So I have to state that. So angle Q is congruent to angle L, and that's because all right angles are congruent because they're all 90 degrees. Excuse me. Now, what else do we know? So let's see, we have a side and an angle. So I could either find something else about another side to have side angle side, or I could find something about another angle to have angle side angle. What do we know? Well, can't I say that this angle is congruent to this angle because they're vertical angles? So we can say that angle NMQ is congruent to angle PML, and that is by the vertical angles theorem. And so now we have a side, an angle, and an angle. So we can use our proven statement. So we can say that triangle NQM is congruent to triangle PLM by ASA congruence. The next thing that we're going to talk about is something called CPCTC. And it just stands for corresponding parts of congruent triangles are congruent. All it means is that if you have two triangles that are congruent, then their corresponding parts are congruent. And we use this a lot in geometric proofs because if two triangles are congruent, then their corresponding sides are congruent or their corresponding angles are congruent. And so this helps us prove a lot of different things, like the isosceles triangle theorem. So this is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And we're going to prove it right here. All right, so our given statements. Line segment AC is congruent to line segment AB. And we can see that here. That's given. Line segment AD, right here, is perpendicular. So remember this upside down capital T represents perpendicular to CB. And that's given. Well, what do we know about something that's perpendicular? So they are right angles, right? So we can say that angle CDA and angle BDA are right angles. Well, not rights, just right. right angles. Whoops. And that's the definition of perpendicular segments. And that's what we learned on our very first day of geometry. We went through all those definitions, that if you have two line segments that are perpendicular, they create a 90-degree angle. All right, so what else can I say? So I have a side and an angle, and this angle, we also know that this one's right. These angles here are right angles, so we could be looking at something with angles and sides, or we could be looking at something like hypotenuse leg. So let's see. This side is a part of both triangles, so I know by the reflexive property that this side is congruent to itself. So I know that line segment, well, I think I'm getting in my head of myself here. So we're going to write that next. So I can say that line segment AD is congruent to line segment AD by the reflexive property. And let me show you why I just left this blank. In geometry, we have to prove everything. So we just set up here that this angle is a right angle and this angle is a right angle. Well, since they're both right angles, now we can say that they're congruent. So angle CDA is congruent to angle BDA. BDA. And that's because all right angles are congruent. It may seem silly because it seems obvious, but we have to prove everything that we know. We can't just assume that the reader knows that all right angles are congruent. Because of the definition of perpendicular lines, we have to state it. And then we came to this part right here where this line is congruent to itself because of the reflexive property. So now what do we have? We have a side, and an angle. Well, we know that SSA is not a valid statement, but we do know hypotenuse leg. Luckily for us, that is what we have. Here, this is the hypotenuse, and this is the hypotenuse, and then this leg is congruent. So we can say that triangle CDA is congruent to triangle BDA. Let me make sure that I got my congruency statements right. Angle C is congruent to B, yep. D is congruent to itself, yep. A is congruent to itself. All right. Gotta always make sure that your congruency statement is correct. And we can say this because of hypotenuse leg congruence. The statement that we wanted to prove was that angle B is congruent to angle C is congruent to angle B. And we can say that because we know that corresponding parts of congruent triangles are congruent. So because we've proven that these two triangles are congruent, we can say that the corresponding pieces, so this angle is congruent to this angle. We could also say that this line segment is congruent to this line segment. We could also say that this angle is congruent to this angle. All of it we know because we've proven that they're congruent. So that's how you use corresponding parts of congruent triangles are congruent. All right, we're going to do two more examples. So here it's given that line segment AD is congruent to line segment CB. Let me mark that up here. AD is congruent to CB, and that's given. Also given is that line segment AD is parallel to line segment CB. And again, I'm going to mark that. I know that AD is parallel to CB. So these are parallel. Well, right now I know that this side is congruent to this side. What else can I say is true? Well, I can say that this side is congruent to itself because of the reflexive property. So I can say that DB is congruent to DB because of the reflexive property. So now I have a side and a side. They don't tell me any other information about any other sides, but I might be able to figure out something about an angle. Here, I think I can say something like this angle down here, right? This angle right here is congruent to this angle over here. Because if I want to figure something out, right, can't use SSS here because I don't have any information about the other sides, right? So I need side angle side if these are going to be congruent. And so I know with side angle side, the angle has to be in between them. And so here, this angle is a part of this triangle up here, and this angle is a part of this triangle down here. Here we can see the angle is in between the two sides, and here I can see the angle is in between the two sides. So why can I say that angle ADB is congruent to angle CBD? Well, aren't they alternate interior angles? I know that they are for a fact alternate interior angles because I have parallel lines and I have a transversal that cuts through them. If I did not have parallel lines, then I could not say alternate interior angles. But because I do, I can in fact say that. So now I can say that, let's see, triangle ADB is congruent to triangle. Now let's make sure we do this in the right order. C, and then we did the angle, so B and D. Let's see. A is congruent to C, that's right. D needs to be congruent to itself. And then B. There we go. And this is because we have side angle side congruence. And then we want to say our proven statement. Our proven statement is that AB is congruent to DC, and we can say this because we know that we have we have congruent triangles, and because we have congruent triangles, we can say that corresponding parts of congruent triangles are, in fact, congruent. What I'd like you to do is pause the video and look at this next problem and see what you can do on your own. So last problem. Here I have two triangles, and my given statement is that N is the midpoint of MO, so this point right here is exactly in the middle of M and O, and that N is also the midpoint of LP, so N is exactly in the middle of L and P. So those are our given statements. Well, now I can say that I know that MN is congruent to NO by the definition of a midpoint. A midpoint is exactly in the middle, so this piece has to be the same length as this piece. So MN is congruent to NO by the definition of a midpoint. For the same reasoning, I know that LN has to be congruent to NP, because if this is the midpoint, then it splits this line into two equal pieces. So LN is congruent to NP. And again, that's by the definition of a midpoint. And we talked about midpoint on the very first day of this unit. So right now I have, I have a side and a side. So I either need to find something about this side over here, or I need to find something about this angle over here to prove that these triangles are congruent. Well, I have vertical angles right here, right? So I can say that this angle is congruent to this angle. So angle, gotta scroll down, oops. Angle LMN is congruent to angle P. Oops, I'm not doing this right. N needs to be in the middle because that's the angle that I'm talking about. LNM is congruent to triangle PNO, or that angle, not triangle. So what I'm saying is it's easier if I could see my picture. This angle right here is congruent to this angle right here by the vertical angles theorem. Oops. Only one R in theorem. There we go. So now I have a side, an angle, and a side. So we've just proven that this triangle is congruent to this triangle. So I can say that triangle LNM is congruent to triangle PNO by side, angle, side congruence. They asked me to prove that angle M is congruent to angle O, and we can see that from our congruency statement. And so because we've proven that these two triangles are congruent, I can now say that these angles are congruent because we have learned that corresponding parts of congruent triangles are congruent.